course, there's always something, right? So we bit of housekeeping from part one there, boys. I actually forgot to mention, right shown on the drawing here, deep inside the evaporator coil itself is actually an evaporator temp sensor. It's utilized by the HVAC control module, as you can imagine, in order to modulate the or to control the air conditioning system itself. The clutch operation keeps the evaporator down near zero, but not below zero. As you can appreciate, the moisture that would condense on the evaporator coil, and that is drained off obviously through the drain line in the plenum. Could it potentially freeze and cause all kinds of problems with flow, obviously, if it was allowed to go below zero. So the system will cycle just above that point in order to maintain its maximum efficiency, with the system actually freezing. That's the point to the evaporator temp sensor. So in this drawing here, it actually shows the plenum itself. The plenum, of course, contains the blower motor. The blower motor, of course, provides the motive force for the air through the plenum. Shown in blue is actually the evaporator coil within the plenum. A wee bit further up the plenum is actually the heater matrix, or the heater core if you prefer. You can see between the two is actually the temp control door, flapper, baffle, whatever you want to call it. But we're talking about the door that actually controls the mix between the two. You can see it's in the full cold position shown there. If it was in the vertical position, that would be full hot, if you can prefer. And yes, all the air does in fact actually go through the evaporator core. That's not to say it's always being cooled, of course, if the system isn't on, but it always goes through the evaporator core, all the air. Not shown on the drawing, just about right here, boys, is actually the pollen filter as well. Not shown on the drawing, but just be aware that is the location. Yeah, so that actuator there, as we'll see on the schematic, is in fact a DC, bidirectional DC motor with a potentiometer for monitoring purposes that actually actuates the door across the 90 degrees of swing that it actually has. I've drawn in some blue and red arrows just actually to show you that what we're talking about in the plenum is a mix of both hot air and cold air, depending on where the temp controlled door is actually positioned by its respective actuator, right? Moving up through the plenum, we actually have the flow control, and there's actually three different small baffles, doors, flappers, whatever you want to call them, all actually moved by the same actuator. In fact, I think it's the same part number for the actuator for the temp control door. The one actuator that is actually different is actually the intake door. I forgot to mention this one here. This is the one that's up by the base of the windshield, by the scuttle there for the intake itself, as I said, just up from the pollen filter. This is actually a different actuator, different part number. It doesn't have a potentiometer. It's actually discretely switched just via some switching, some trace switches inside the actuator itself. So that's the three actuators we're talking about when we look at the schematic, boys, just so you can appreciate them. Okay, so we've seen where all the components actually live and their physical locations, and we've talked a wee bit about their functionality, boys, but here's the actual schematic. Now, there's obviously a lot of detail on here, right? So I'm going to go through it fairly quick. So it's not going to be very comprehensive. I'm going to do it fairly quick in the interest of making this video a reasonable time frame. So up on the again, the color coding, boys, anything that's shown in yellow is actually an input sensor of some sort. Anything that's shown in orange is basically a processor or a module of some sort. What do we actually have as far as a module, processor, or a controller? We've got the blower motor controller that I mentioned before. We've got the HVAC module itself, the large box outlined in orange in the middle of the drawing. We also have the engine control module, and we also have the body control module. There's also some other modules that are interfaced via the CAN bus on the drawing, but we can understand that those are maybe secondary issues to the actual understanding of the climate control system. Believe it or not, the wheel speed sensor is actually an input into the system. Can you imagine that the faster the car goes, depending on the outside temperature, there is either some ram air, there can be a ram air cooling effect on the system, which is all factored into the algorithm in order to process the calculations. So there is some peripheries that are actually taken into consideration, believe it or not. And that's done through the ABS module, of course. The wheel speed sensing is done through the hub, forwarded to the ABS module. The ABS module, as I said, via the CAN bus, actually talks with the other modules in the system, namely the body control module or the engine control module. While I'm talking about the engine control module, you can see here two items that I should discuss actually right away there, boys, is the compressor relay and the compressor itself in the AC system. Of course, this is just power distribution. The boxes, as you can imagine, there's a distribution box and a J box that contain the fuses in the car, but I think you guys can imagine that there is some degree of power distribution, of course, to carry out these functions. The compressor relay and the compressor itself shown up in the on the drawing here, items 21 and 22 there, boys. I don't know if you can show them. Maybe I should zoom in a wee bit. Maybe a wee bit better. The control of the relay is actually carried out via the engine control module. You might think that it's done by the HVAC module, but it is in fact done by the engine control module. I think this is done in the interest of simplicity between the two models that have the manual air conditioning and the full climate control module. Of course, the manual air conditioning doesn't even have this module, so in the interest of simplifying the design, I think between the two cars, is done in this manner. So basically the HVAC module is communicating to the engine control module over the bus, telling the engine control module to actually apply the ground on or off to the relay in order to control the mag clutch in the compressor. So I hope that makes some sense to you. There is also a relay here showing item 26. Item 26 is actually the condenser fan relay, and item 20 is actually the condenser fan itself. It's pretty simple operation actually, guys. So long as the AC clutch is engaged, basically the compressor fan is running. It's pretty much actually as simple as that. So over to the left hand side of the drawing, you can see we have the plenum blower itself. It is actually controlled via a blower control module. It is not a simple relay module, a voltage divider in the old school AC systems. It is on the manual AC cars, SX4s, but not on the climate control. There is actually some active electronics. What is that, like a MOSFET or something in there, actually being controlled by the HVAC module itself. And basically what they do is actually they apply a differential voltage across the fan in order to control the speed. As you can imagine, if you have 12 volts on one side of the fan and near ground on the other, you're going to have maximum speed. But if you ramp up the voltage on the ground side, the ground side, say we take this up to 10 volts, the fan is going to run at a very low speed. 8 volts, a little faster, 6 volts, a little faster still, and you get the idea. So that's how it actually controls the blower speed, operating in the AC mode, in the automatic mode, of course. Of course, it can actually be controlled manually as well if you take the rotary switch out of the automatic mode of operation. The cabin temperature sensor, this is the one where the air is actually drawn over it via the aspirator or venturi type assembly, if you will, in order to continually refresh the air that's going over the sensor in order to keep the response rate of the sensor high. And you can see that it is just a thermistor applying the a voltage. Basically, it's just dropping the voltage to ground depending on the resistance of the thermistor itself, and that's interpreted via the HVAC module as a particular cabin temperature. The evap temp sensor actually works the exact same way. Item 15 there. Operating slightly different is the sun load sensor. Yeah, its value will actually change depending on how much light intensity is actually applied to it. We can take a look at that out on the car a bit later, but it's actually all factored into, again, the calculation as far as the degree of AC load. The 3 items shown in blue there, guys, you can see is in fact the 3 different actuators that we spoke of in the plenum. The temp control, splitting the air between the evaporator and the heater matrix, and the flow control for the up, out, and down flow of the actual air in the plenum. These two, I believe, are actually identical. You can see a reversible DC motor, of course, in order to get the actual control, and the position feedback coming from nothing more than a potentiometer. Kind of an interesting design here. You can see the driver circuits. Because it's bidirectional, you can see that it's kind of an interesting layout. 4 transistors. One of them would apply the power and the other one apply the ground, and then of course when it wanted to drive it in the other direction, the other 2 would come into operation. So 4 required for bidirectional control. 1 for the ground, 1 for the power, in both directions, for a total of 4. So kind of an interesting design there. Subtle difference between the intake actuator is the fact that it doesn't have a position potentiometer, and you can also see there's a diode on one side of the motor. So this leads me to believe it's actually driven continuously only in the one direction. Of course, it stops at particular points in order to have a fresh, a recirc, or a mix configuration in the plenum. But you can see the driver circuitry is actually quite different. And as I said, that diode there tells me that it must be unidirectional. It'll just continue to rotate in the one direction. Although it can constantly change its position between fresh, recirc, and mix in the one direction. It is only the one direction that is driven in, I believe. We'll actually take a look at that on the car itself and confirm that, but I believe that is the case. Yeah, some details there that probably nobody really cares about, if you even care about this detail. Here is the panel itself here, boys. The temp selector, the blower speed, and the mode selector, they're actually all potentiometers, and again interpreted via the HVAC module itself for the different requests. The temp select point, the blower speed, and what mode you want, up, out, or down, again with respect to the airflow. Couple of enunciators on the panel that are telling you the status of the operating mode, what status it's actually in, whether the AC system is actually on or not, a little LED, whether you're actually in the fresh or recirculation mode with respect to the intake door. What else is on here? Go across, we can actually see some detail. Again, the hatching, guys, is just detail with respect to the rear defroster that nobody really cares about. You can see here we have a line from the HVAC controller back to the body control module, just telling the system whether the AC is actually engaged or not. I'm sure for load monitoring purposes, perhaps electrical load monitoring purposes. The K line for diagnostic purposes on pin, what was it, pin 7 if I'm not mistaken. Yeah, pin 7. We looked at that a couple of weeks ago, actually, when I was actually studying the K line. I should have made mention. It sounded kind of stupid in the video when I actually was discussing it, that the K line is for diagnostic purposes only. I realize that, guys, right? But I thought there would have been activity on the K line so long as the scan tool was actually hooked up to the data link connector. That's not the case. Even with the data link connector hooked up, the K line goes dormant. You need to actively be interrogating a module for the K line to actually be active. That's what I was trying to get that across. It didn't come across in the video and actually sounded kind of stupid. Yes, I know the K line is for diagnostic purposes. Interesting on the drawing here, boys, you'll notice it's not CAN bus arrangement with a twisted pair there. There is a serial bus communication line, and it's only shown as a single line. Why? I'm not sure. Perhaps it is only a single line and it's not CAN bus data transfer, but a different bus yet again that I wasn't aware of on pin G20C13 between the HVAC module and the body control module. I'll have to look into that a wee bit deeper. The outside air temp sensor, again a thermistor there, boys. Simply dragging down the 5-volt supply depending on what the outside temperature actually is. yeah, simple enough. Very similar to the cabin temp sensor and the evap temp sensor. In fact, near identical, except for the physical proportions, I'm sure. The engine coolant temp sensor, we spoke about that, and that's obviously important for the system to know what the engine coolant temperature actually is with respect to the heating and how much heat the system can expect to draw from the heater matrix. Of course, a function of the engine coolant that's circulating through it. The reference pressure, refrigerant pressure, there's a sensor there. You can see that that's actually, again, it's no input into the, strangely enough, the HVAC module, but the ECM. Again, I think that's for commonality purposes between the automatic air conditioning and the manual air conditioning available in the cars, just to keep the option changes to a minimum, I think. A line that actually tells the engine control module, the blower load for engine idling purposes, maybe stable engine stabilization purposes. It wants to know how much load the blower actually has on it electrically. And what else is on here? I think that's just about it, boys. Yeah, I mean, yeah, I think that's about it. Listen, I know that's a lot of detail, and I've probably lost a lot of you along the way. There is the pinout of the connector that's on the back of the HVAC module itself there for testing purposes, shown on the drawing. I know that's a lot of detail, but some guys actually like this kind of detail, right? I like it. I'm really interested in climate control systems. If I wasn't, I wouldn't be looking at this drawing to this degree. But anyway, I hope that gives you some idea what's going on with the climate control system. I'm going to actually make a third episode to this mini-series, guys, with respect to climate control. The reason being, this episode's obviously running long, but I really want to get some scope action on with some of the sensors and actuators, or at least the actuators. I definitely want to take a look at the control and the feedback from one of the door actuators. And I also would like to see if I can make some sense of the serial bus, which is only a single line. That's a bit of a mystery to me. And what else? Oh yeah, I'll hook up the VPacker and we can actually look at some of the data streams. That's it, boys. I hope that made some sense.